let's consider this problem for a bit. Let's examine it and compare it to the equations we've been working with. We've been working with linear equations in one variable. And remember the characteristics. It was an equation, which was told to us by the fact that it had an equal sign. There was only one variable, and the exponent on that variable was 1, which is what made it a linear equation in one variable. If we think about the characteristics of this particular problem, which again is an equation, again the equal sign tells us that, but one of the main differences we see here is that this equation contains two variables. Once again, though, the exponent on each of the variables is 1, which makes it a linear equation. So what we are dealing with here is a linear equation in two variables. When we find a solution to an equation, we're always finding the unknown number, or in this case, it will be unknown numbers. Remember, that's what a letter in an equation represents. It represents an unknown number. When we find a solution, we're finding that unknown number, or numbers, that will make the left-hand expression become identical to the right-hand expression. So in this case, what we are looking for is we are looking for a number we can put in place of x, and a number we can put in place of y, that would make the left-hand expression become 12. Now, if we think about that a little bit, we probably could come up with some solutions just by inspection. One possible solution would be if we were to let x be 0 and let y be 4. That would make the left-hand expression become 12, wouldn't it? 2 times 0 is 0, 3 times 4 is 12. 0 plus 12 is 12. So letting x be 0 and y being 4 would produce a solution to this equation for us. But that's not the only solution we could find for this equation. If I were to let x be 6 and let y be 0, I would also have a solution, because that particular pair of numbers, x being 6, y being 0, would make the left-hand expression become 12 as well. 2 times 6 is 12, plus 3 times 0 is 0, 12 plus 0 is 12. So we have a second solution to this equation. Oftentimes, solutions to linear equations in two variables, oftentimes we write those solutions as what we call an ordered pair. This is how we would represent the two solutions we just found in ordered pair format. In an ordered pair, the first number listed is always the x number, and the second number listed is always the y number. So here we have two solutions to that linear equation in two variables. Now, we might ask ourselves the question, would there be more solutions? And the answer is yes. What if we let x be 3 and we let y be 2? 2 times 3 would be 6, plus 3 times 2 would be 6. 6 and 6 is 12. And we've now found 3 solutions to this linear equation in two variables. Are there others? Well, how about this? What if I let x be 9 and I let y be negative 2? 2 times 9 is 18, plus 3 times negative 2, that's negative 6. 18 plus negative 6 is 12. And we have found a fourth solution to this linear equation in two variables. Well, what if we let x be 12 and we let y be negative 4? 2 times 12 is 24, plus 3 times negative 4 is negative 12. 24 plus negative 12 is 12. In each situation, when we replace x with the first number in the pair and y with the second number, the left-hand expression becomes identical to the right-hand expression. Those are solutions to this linear equation in two variables. There are an infinite number of solutions to an equation like this. With a little bit of work, we could continue to find solution after solution to this linear equation in two variables.